I have the great opportunity to introduce our first speaker today. Robert M. Lee is the CEO of Dragos Corporation. As many of you know, CERIAS has been the lead technical university for CyMani, which is a Department of Energy initiative for cybersecurity for advanced manufacturing. Before that, we'd already ventured quite deeply into the area of cyber physical security and ICS. But along the way, we've had this great opportunity to call upon expertise at Dragos and have built a relationship with their president. So it is our great honor to actually have him for the very first time here on campus to give a talk. So, Mr. Lee.
I'm going to thank you.
Welcome.
Come down the aisle like a wedding. So this is good. Yeah. Awesome. All right. So you just want me to jump right into it? Are you done? Awesome. Perfect. Well, thanks everybody. Appreciate your time and attention this morning. As mentioned, I'm Rob Lee. I run a company called Dragos. Past life, started out in the Air Force side of the house, spent most of my time over the National Security Agency, built out the US government's mission looking at state actors breaking into industrial sites around the world, and then spent time on the offense doing similar to other people. So fun stuff. And my talk today is not going to have slides and PowerPoint, so you're welcome in advance. My head of Intel would always tell me that PowerPoint and indicators of compromise were very similar in the fact that they're absolutely pointless, but if you don't use them, you look stupid. But we'll accept the stupidity and just talk anyways. But my talk today is really around the industrial cyber trends. So I'll touch on the threat landscape, but I also want to touch on some of those boring things like policy and some of the things that are happening with governments around the world on this topic. So just a little bit of a catch up here for those of you that may not be industrial folks. So when we talk about industrial control systems, that ICS stuff, we'll usually use the term operations technology or OT instead. Big reason for that is a lot of our industrial control systems that we talk about tends to be power, water, gas, manufacturing, pharmaceuticals, et cetera. But then a lot of the other industries with physical systems like aviation and hospitals were like, hey, what about us? HVAC systems for a data center as an example. Hey, what about us? So we all just kind of agreed, fine, we'll just call it OT. But still in the industrial sectors, they'll mutter under their breath, like, yeah, we're doing ICS instead, just to make fun of those OT folks. But either way, broader coverage of OT also tends to make sense when you talk to board of directors and executives. Hey, you've got your enterprise IT stuff. Over here's your OT stuff. So it works. But the idea, the thing that's important here is that it's really all the stuff you have in IT plus physics. That's what OT is. Okay, that's the easiest way to think about it. A lot of folks will say things like, oh, IT and OT convergence. Stop that. In case that's y'all, just knock it off. Okay, convergence happened about 20 years ago. We have Windows operating systems in a power plant. We've had it there for a long time. We've had CP cards on the side of an ABB RTU, and all those different acronyms just mean specialized controllers. So we've had convergence. What we're seeing now is kind of hyper digitization, hyper connectivity. Some people call it like Industry 4.0 or digital transformation, depending on which big four auditing firm you talk to. And ultimately, what we're seeing is all this stuff that we've usually had as analog, disconnected, kind of serial stuff being highly connected and accessible, not only by adversaries, but by our own folks to do new cool things like data modeling, forecasting, better manufacturing, lots of fun things that we can do with those advances. But of course, the point is still physics. So for those of you that also look at these systems and think, oh, well, they're changing, maybe one day we'll just have IT security stuff in that operations environment, I would caution you against that. If we look at the IT security controls, they were built with what? They were built with IT security threats and risks in mind. If I have a Windows operating system, I really care about stopping somebody from getting onto that system, escalating privileges, stealing the data off that system. That's the stuff we care about. It's system and data security in IT. In OT, we care about systems of systems and physics. That's what we're worried about. The fact that we could lose data sucks. Like, we don't want to lose data. There's a lot of interesting intellectual property in those environments. The intellectual property for a manufacturing company usually isn't the recipe or the trade secret around the recipe. Usually it's the actual industrial automation environment itself. How did we tune up to take low quality inputs and make high quality outputs with that set of industrial automation? That's the intellectual property. That's not stored in your email server. That's in your operations environment. So Yeah, intellectual property theft happens there, but what we care about a lot is that physical side of life and safety, right? Just making sure that people are taken care of. So if you take IT security controls that are designed on one set of systems against one set of risk, with one set of impact, with one set of threats that operate in one set of ways, and we look at an operations environment with different risks, impact, threats, vulnerabilities, and adversaries that operate in different ways, the idea that we would just copy and paste one set of controls into another environment seems pretty silly. And yet, what do we do when we walk into an automation environment? Oh my gosh, this legacy equipment and it's unpatched. Cool, let's set a stage here. How many ICS or OT vulnerabilities known at the time have ever been used in any industrial attack? Zero. And yet, the first thing we yell at operations people about is unpatched systems. It's an IT mindset, okay? So you walk into these environments, you kind of got to take the bias and the baggage and put it off to the side for a second. Actually, one of the most impressive things you can do in one of these plant environments, walk in and find the oldest, crustiest looking engineer and just say, hey, what are you worried about? Oh boy, that turbine over there, woo, that thing goes, run that direction. Like, okay, thank you. I appreciate you identifying your crown jewels. And now we know where to start on the things that actually have risk in that environment, right? That's probably going to get you a lot further than maybe a safety standard or a cybersecurity standard. All right, so that's a IT versus OT, very, very high level, but everything that you interact with comes out of OT. The chairs, the computer, the mobile phone, everything. Industrial is the world, which was very funny to me in my own journey when I went to start a company and all the venture capitalists out there were like, well, why aren't you doing stuff in cloud or like apps? I'm like, it's everything. What's the size of the market? I don't know, the world, like it's everything. And there's a lot of people who misunderstand just how pervasive all this automation is. All right, so that's that piece. So what's been going on and why are we all worried about it? Well, years ago, we dealt with, I would say, kind of ICS curious threats, okay? I put them into 3 buckets: ICS curious, ICS capable, and assholes. Okay, we're gonna come back to that last one. All right, so ICS curious was those threats that started out going, I don't really know this industrial stuff, but that's an industrial company, like a power company, and I bet if I break in, there's something there for me. Let me see what I can do. Let me see what I can learn. So it was a general curiosity. And they're breaking into places like pipelines and so forth, but maybe not really being in the industrial side of the house yet. They were trying to get into those operations environments, all right? So those ICS curious threats. And that really lasted up until about 2009, 2008, 2009 timeframe. A lot of those threats kind of captured that bucket of not really in automation environments, but really curious about it and trying. Then we kind of got quickly into this phase where we had a bunch of different threats that were ICS capable. And they got into the automation environments. They started stealing the right data sets, taking data historians and engineering work drawings and screenshots of human machine interfaces, not stuff like credentials and passwords, but stuff that showed they understood that they needed to understand the physics of the environment if they wanted to cause disruption or an attack, okay? And so they were capable. They were in the environments and they're starting to develop knowledge and capabilities. And this is a really important sort of tangent. To do the types of attacks we're concerned with most in industrial automation environments does not require exploits, vulnerabilities, or malware, which makes up a significant portion of what we care about in IT security. And that's not saying you can't use those things, it's just not required. Because of the systems of systems nature, a lot of what we deal with in automation environments is native functionality. If I can open up a circuit breaker, so can the adversary. If I can change the logic on a safety system not to activate in an unsafe condition, so can the adversary. It doesn't require vulnerabilities, exploits, and malware to do those things. Now, you can use malware to make it more automated. You can make it more scalable and repeatable, but you don't need it, okay? So it doesn't have to be a capability that's developed. It can just be knowledge. And that's what those ICS capable adversaries were doing. Now, we did have that S word that dropped in Iran that you can't get through an ICS presentation without somebody mentioning. Too bad we'll never know who did it, but it was a very interesting attack, and that's true. But for that whole era, I would say we were mostly dealing with the capable adversaries, the ones that hadn't done destruction or disruption yet. It was mostly espionage for capability development. Then everything changed in 2015, and that got us into that next era of ICS assholes, if you will, people that are targeting civilian infrastructure. So I hate to cuss in front of a prestigious audience, That being said, when we're talking about people on the other side of the world that are trying to kill civilians, hopefully we can all agree there's only one word that actually captures that correctly. So when we look at these adversaries and we look at 2015 and what changed, the first ever cyber attack to take down electric power took place in 2015. And that happened in Ukraine across 3 regions of Ukraine in December. And it was December 24th, technically, but I'll always remember it because I was getting married December 25th. And I got the phone call from a counterpart. I had just left the government like 3 months before. I had been previously stationed in Europe and had kind of all these counterparts across Ukraine and everywhere else. I got a Ukrainian counterpart calling me up going, "The power's down." I'm like, "That's cool, man. I don't really care." Click. Called back. He's like, "No, you don't understand. I bet it's a cyber attack." And I'm like, "It might be squirrels. I don't know." Click. It's like, when you look like me and you serve in the military and you get an opportunity to get married to somebody that looks like my wife, you take that opportunity, right? Like you just make sure you jump on and get on the ship. So anyways, I keep ignoring the phone call and I'm really focused on trying to get married the next day. And I get a phone call then the next morning from a man that was my mentor and peer, Mike Asante, and he called me and said, "It might be real." It's like, God bless, like, let me wrap up this wedding. And so I talked to my wife and she was really nice about it. And so we finished the vows and then I left. Anyway, so I got to investigate the Ukrainian attack. I'm losing a lot of audience points, I feel, at this point in the story. Anyways, I got her a honeymoon in New Zealand after it, okay? Like, calm down with all the judgment. All right, but so I get to go do the investigation in Ukraine. And what was interesting was it was exactly what I just mentioned of knowledge, not capability. And yet, all the world was talking about black energy malware in the IT networks. That's what caused the power outage. That's not how physics works. And you can't just deploy something in an IT network like that and cause a power outage. That's just, it does not work that way. So it didn't make sense. But what we knew and what we had from all the data and the insights was the adversary used black energy malware to get into the IT networks, but then just used the connections that existed between IT and OT, got over to the OT networks, learned the environment, spent 6 months in that environment learning how to operate the systems, and then executed the attack. And that attack really was just operating like an operator, just opening and closing circuit breakers and de-energizing the electric system. It scared the hell out of governments, but every electric engineer and operator out there was like, "Yeah, no kidding, of course you can do that. What are you worried about?" Now 2016 scared them, but this is an important part of the story of 2015. So then I get the illustrious duty to go brief the National Security Council and the White House and various individuals that don't like to be named there. And talking to them, it was very clear that they were stunned. They were like, "Well, poor Ukraine. Well, at least that can't happen here." I'm like, "What? Sorry, what are you talking about?" Well, look at all the cybersecurity work we've been doing across critical infrastructure. Look at all these efforts, look at the NIST standards and look at NERC SIP and all this other stuff. I was like, "Yeah, you do know, though, that's on the IT stuff, right?" And they're like, "What's IT?" And I was like, "Well, that's not the OT stuff." And they're like, "What's OT?" And I'm like, "Oh, we're screwed." So I started educating them on like the differences. And I was like, "Look, all these presentations you're getting and all these CEOs that come talk to you about the investments they're making, they're not lying, but they're talking about the enterprise IT. You are talking about the enterprise. Really different, really simple terms, big difference and big impacts." So the White House started calling around to the different companies and execs and going, "Can that actually happen here?" And the power companies deserve a lot of credit because all their CEOs were like, "Yeah, it's what we've been warning you about. Of course it can happen. And we are not actually able to make these investments because of the regulated ways that were run and the public utilities commissions and all sorts of other stuff." And so the government started freaking out. Because if you can think about it, prior to 2015, their viewpoint was this is handled. And sure, there's always going to be more cybersecurity stuff to do, but at least we're doing a lot. To find out that they weren't doing anything on the critical part of critical infrastructure was terrifying. So at that point, we started seeing the policy world actually get much more aware of the terminology like OT. One of the reasons I do push back on the cyber physical system thing as a quick tangent, it is accurate, but your policymakers, executives, board directors, everything else have learned the term OT. Let's just stick with one instead of coming back the next week and be like, "Actually, we call ourselves differently today." Like, okay, maybe not useful in policy settings either. Anyways, so we absolutely started talking and digging into it, and their perception was, "Yeah, we're screwed." My perception was, "No, you're not. Our infrastructure providers have built safe and reliable networks, safe and reliable systems. They didn't do it with security in mind. But that safety and reliability culture absolutely contributes to security. If you are resilient, then you're resilient in general, okay? And that's very useful. If I can bring back up the power from a hurricane, I can do it from a cyber attack. Now, I can't do it with 3 or 4 of them happening at a time because we don't train for that. So like one little instance, don't freak out. If somebody comes at us in a combined way across a couple different sectors or sites, freak out, right? Those are your levers. So there's a lot of discussions, a lot of like, okay, how do we deal with this? And then by the time a lot of these conversations were taking place, the second attack happened. And that was in Ukraine in December 2016. And what the adversary did, which was very clever, is they just learned from all the things they did in 2015 and put it into automation, software, malware, right? And call it crash override or in destroyer. And so that malware was then able to work on the transmission side of the house. And one transmission site they took down was 3 times the overall power loss of everything in 2015 because it was at a distribution level. So now your engineers and operators and electric engineers were freaking out because the idea that somebody can jump on and use a distribution management system to open up a circuit breaker, who cares? The fact that somebody can build a protocol-aware software stack to automatically disconnect transmission substations across the country, terrifying. And this is where then I got invited to testify in the Senate. And in 2018, here's the story I told them. All right, and this will kind of bridge us into the next chapter of the talk here. The story I told them was, don't freak out. There are a lot of things we can do. And I hate when defenders make these statements. And it's okay if you have made it. Just because I hate it doesn't mean it's wrong. But I always hate when defenders make statements that I feel are very disconnected from reality, such as, well, the adversary only has to get one thing right. Defenders have to protect everything. Man, none of you have been adversaries, apparently, because that's not true. If you're on the adversary side of the house, time is on the defender side. Because the moment I compromise your network, compromise your environment, any data and logging that you have for as long as you're storing it is a loaded gun waiting for me, okay? In other words, I have to anticipate maybe you have 2 years of logs that I'm not clean out of that operation for 2 years. Because you've got 2 years worth of data to go back and find that operation. And if you find the operation, you find one thing and pivot in the investigation, you can also start linking it up to other companies and other operations. So actually, from a defender standpoint, as an adversary, I can take down one defender, but one defender can take down hundreds of adversary operations. So I really hate that one. But anyways, the point is, a lot of these things we throw out that sound good lose their traction really quickly. And so what I told the Senate was, we actually can do this. Defense is doable. A couple basic security controls, not next gen AI and blockchain and ChatGPT, but just basic controls can put us into an amazing place. So let's go invest on those. I said, but here's the warning. And this gets us into the phase of where we are now. I said, we have heterogeneous systems right now. These heterogeneous systems mean that the oil refinery in Texas has nothing to do with the oil refinery in Saudi Arabia. The electric substation in DC has nothing to do with the electric substation in California. The physics profile, the implementation of the automation, the vendors, the OEMs, the integrators, it's all different. Very heterogeneous, which means the only attacks we see that are disruptive or destructive are usually site-specific or sub-industry specific. Crash override didn't work on every piece of electric environment, let alone all the different industries. It worked on transmission substations. The CERIAS attack, which was malware deployed at a safety system in Saudi Arabia that they actually tried to kill people, they screwed up the attack, so they only cost the company $300 million in downtime, but they were trying to kill 30 to 60 people that day in the first ever cyber attack to target human life. That one only worked at that facility. The style of the attack, the blueprint, the tactics, techniques, procedures, sure, you could reuse those and teach people how to do this, and that's dangerous. But that attack, that malware, only in that site. One of the reasons I was always laughing when people were like chasing around the community, passing indicators of compromise out for CERIAS. I'm like, that makes sense. Like, it can't work on any other safety system. Focus on the behavior, not the indicator, okay? Anyways, so we dealt with single site, maybe sub-industry. I told the Senate in 2018, I said, look, my concern is because of this digitization, because of the advancements we're making in the industry, for all the right reasons. We don't want somebody to get trained up at Cherry Point Oil Refinery and then go to DeMom and not be able to transfer the skills. Doesn't make sense. From just workforce development and sustainability, we got to move towards this homogeneous infrastructure. But when you move towards homogeneous, you get scalability. If I'm a kid today that wants to go learn how to compromise companies, I can set up a Windows domain controller environment in my basement pretty quick. I can set up some EC2 cloud infrastructure, mimic a bank. Setting up a power grid in your basement's kind of hard. It's like not the simplest thing to do. So it's hard when it's all that heterogeneous complexity. We move towards homogeneous, where we have common operating protocols, common stacks of software embedded in other controllers that we don't even know about that's common. It gets dangerous. And I warned in 2018, I said, within the next 4 to 5 years, I bet we see an adversary come out and take advantage of that. Almost 4 years to the date of my testimony in 2022 is when we saw that. So I'm going to spend a second on what this is, make sure I'm on time so SPAF doesn't murder me. I'm going to spend a second on this one because I think this one's important. So in 2022, in January, I'm going to use some lawyer language here for a second. Dragos, during the normal course of its business operations, was contacted by an undisclosed third-party partner of ours, and we were handed software that we were to analyze and to help them out. Cool. All right, got that down. Now what happened? So essentially what had happened is I had told all of our partners that have various sources of telemetry and data in the world, right? We reach out to not security companies, but you reach out to like telecom companies, you reach out to software providers, cloud providers, et cetera, and say, hey, if you ever see this kind of stuff, call us, right? That's the kind of relationships that exist in the industry. And I said, hey, on this ICS stuff, I know it can be really hard to figure out if it's even relevant, but let's look to the past, because I'm prior life doing Intel. I don't like predictions. Intel we don't do predictions. We do forecasting. Predictions is here's what I think can happen. Forecasting is here's what I've seen happen and what it might mean about the future. So I said, look, I don't want to be the company that gets caught missing something we've seen before. So, hey, partners, here's a couple things that I think you should look for. If you ever see anything that talks about like OPC as a native protocol or Modbus TCP, we've seen these two be abused in the 2015 and 2016 Ukraine attacks. So if you see anything with those terms or whatever in the metadata, like we want that one. If you see anything that looks like it can modify controllers, like it can do east-west from like an HMI or human machine interface down to controllers, like we've seen that before in that S word. If you see anything that looks like it's actually living in firmware or injecting the memory on a running controller, we've seen that in Trisis. And if you see, you know what, just to throw one out there, kind of a prediction, but if you see anything targeting codices, because one of our researchers, Reed Whiteman's one of like the smartest researchers on the planet, and he's always freaking out about codices. I'm like, all right, give him one. If there's anything codices related in like software you find, let us know. And I think it was like a couple months later, so it was January. I get a phone call. Hey, remember those things? I'm like, yeah. Did you find one with one of the 4 modules? And they're like, oh, we found something with all 4 modules. I was like, oh, cool. I'm probably going to have to brief the president. Like, could you authorize me to share this with parts of the government? And the reason why I mentioned the brief the president discussion is like the president doesn't care about cybersecurity 9 times out of 10. But when you talk about somebody, and particularly a strategic adversary, creating a capability that is explicitly designed to destroy critical infrastructure around the country, like that's like they care, right? That's one of those things. And so got permission, started working with NSA, DOE, FBI, DHS, because we had to list all of them. We really just worked with the NSA, but everybody wants credit. That's fine. Anyways, so CISA was a great partner, and they were very helpful. Thank you for your MFA. Anyway, so the discussion quickly evolved, where as the Dragos analysts were tearing this apart, every piece that we looked at started getting worse and worse and worse. And what Pipe Dream really is, that's the thing that we called it. What Pipe Dream really is a collection of software utilities, a collection of malware that allows it to operate in any industrial environment anywhere on the planet. Okay, so anywhere it can be at least a good espionage tool. In most environments, it can take down the environment. And in some environments, depending the physics profile, it can destroy the physical equipment. And this is the piece that gets everybody uncomfortable. That same adversary had picked out 13 targets across the United States in liquid natural gas and electric. And our assessment of what we were seeing was that these were 13 targets that, as the Ukraine conflict sort of heated up, that these would be strategic sites to hit. So can't say who it is, but you can't guess and be wrong, by the way. Anyways, anyways, so it is a first time ever that we've seen a cross-industry, repeatable, reusable, scalable capability to do destruction. Hell, you can put it on a remotely piloted aircraft to mess with the servo motors. Like anything physics and networked, this thing works. That's terrifying. The worst part is there's no fixing it. There's no like vulnerabilities that's taking advantage of it. It's all the native functionality across the software stacks. So this isn't like I'm going to patch or like install a new software update and I'm good to go. It's not how it works. You better be doing detection and response like in these environments. So Pipe Dream kind of gets us to that place of worry. But what's the cool part of the story? It wasn't used. That's why like a lot of the community is not talking about it, is there was no big explosions, because the way we went about our business was to get this before the adversary employed it. I've been coached lawyers on that term too. Employed it doesn't mean that it wasn't deployed somewhere in the world for testing or whatever, but it had not been employed at the actual targets yet. And the government, the US government, was actually heavily involved with this with us. So to me, it was one of the best public-private partnership wins I've ever heard of. Usually they throw that term out. Public-private partnership, it means nothing, almost as much as information sharing. Okay, whatever. But this one actually getting to work it in real time and making sure that the adversary didn't achieve their objectives at that time. Now we bought ourselves some time. You still got to do something with that time because they can just reuse that thing again, right? So got to heat it up. But now we're in this era where we're not dealing with ICS curiosity. We're not dealing with somebody can cause an attack in a power sector in Ukraine and we have a year or two to learn. We're now dealing with capabilities that can be deployed, reemployed, and used across industries. Time's up. Okay, I'm not a hyperbolic person. For most of my career, I've like destroyed all the journals that come out and be like, oh, they sent a phishing email to the grid, it's going to go down. Like, not how physics works. So I've always destroyed the hype, but I'm delivering a message to the community this time and testified to the Senate 2 weeks ago or something about it again, kind of came back. I was like, I told you what I told you, and here's what I'm going to tell you again, kind of thing. The point is time's up. And so we got to think about things differently. And there's a lot of different areas of research. And so I'll kind of end the discussion or start taking the discussion down this route and then open up for questions. There's a lot of areas for research. And I see some really cool stuff coming out of academia. So here's some things I would advise you on. And right, I'm just some random dude with a beard. Advice number one, don't recreate what's already in the private sector and don't think you're going to be resourced to do it better. So I talk to the national labs about this all the time. I love the national labs. They're great partners. That being said, I cannot, and I testified in front of the Senate to this, I cannot name one cybersecurity technology that's come out of a national lab that they've made in the last 20 years that is still viable or used anywhere in the industry. Not one, although we spent billions of dollars doing it. Why? It's not that they don't have brilliantly smart people, they do. But if you look at the ecosystem behind funding, I can go raise $400 million in the Valley to go put effort on anything at the same time that a researcher is struggling for a $5 million grant. And so you've got really smart people, and I'm sure that innovation can come out of places like this. It's all the others, it's not you, okay? But I would tell you, yeah, just be careful of recreating or doing a 5% increase on something that already exists. But there are things that are really long-term and strategic. Idaho National Labs knocked it out of the park recently when they looked at cyber-informed engineering. And what they want to do there is think about how we're designing the electric system of the future and see if we can design some of the risks out at a physics layer. We're worried about the valve opening 70 degrees. Let's max it out at 30. What's the profile that's actually usable? What's the profile that we actually care about? Let's design in physical limitations. Now, you can't design all the cyber risk out, especially that native functionality, but you can remove some of really important stuff. Now, I will caution you, especially if you ever hang out with policymakers, they talk about that as like going back to analog. We don't use those words, okay? That upsets the electric providers. It's not analog, it's next generation non-digital assets, okay? That's the term. Anyway, so some of the stuff just simply doesn't need to be connected to the internet, all right? Some of it does. This whole idea of like, I can't believe people with ICS connected to the cloud. Oh, okay. We connected an oil refinery to the cloud and saved, I think, $480 million a year. Yeah, we're going to connect that stuff up. That's going to happen. But let's talk about the security around it and how to do that, okay? So think about those longer term investments. Think about the things that can be really impactful by thinking about the problem differently. If you're coming up with yet another IDS or yet another antivirus product or yet another application whitelisting source, like I'm just telling you, it might be good for your development, might be good for your education. Don't think it's going to put a dent in the problem. What's the biggest part of the problem? Resourcing. Like CISA just launched it. I don't always beat up on CISA, but I'm doing it twice, so I have to apologize now to CISA in advance. Not to like send Jen a tweet or something, but CISA went and testified to the US government that they needed resources so they could go around and do cybersecurity assessments at water companies. There are 55,000 water companies in the United States. About 54,000 of them don't have resources. More than 30,000 of them share one IT person between minimum of 2, but usually 6 water utilities on a contract. They don't need AI, blockchain, cybersecurity assessments. They need basic IT support. They need a firewall. Okay, like that's the level of where our infrastructure is. So a lot of the security solutions get designed for kind of some of the top end companies. But if you're talking about actually making a dent in the problem, figure out how to have something scalable and repeatable for all the people that need the basics. That ends up being really good contribution. So that type of stuff. And then when it relates to industrial control systems, remember the system is not the point. So as you go look at vulnerabilities and research it and like fuzz it and all that stuff, please appreciate that it's a system of systems. So nobody actually cares if the engineer workstation gets compromised. But did the engineer workstation get compromised by somebody that has the knowledge to modify the controller to cause an impact that's physical on system 3, system 1 to system 2 to system 3? Now we all care, whether it's an adversary or an insider. So understand the place and the role that it has before you prescribe security answers. I see a lot of folks that want to tell me how to secure the control system, but in the environment of systems to systems, you're doing worse. As an example, various folks keep asking for TLS or encryption on the ICS protocols. That's a bad idea. Sounds good. We're going to encrypt the protocols. Cool. Against what? Well, man in the middle. Like, what pen tester hurt you? Like, what? When have you seen man in the middle attacks in an ICS network? And also, if they're in the ICS network doing that, they own the endpoints and the encryption is irrelevant, but now you can't monitor it. So before you prescribe the security answer, understand the context of how it's going to be used. Think about that system of system, then think about the mission of the site. When I try to tell people getting into OT, they're like, I want to get into OT. I'm like, awesome, we need you. Come on in, the water's warm, okay? But take a box of donuts and a case of beer and go talk to an engineer first, okay? Go talk to the people at the substation, the manufacturing facility, et cetera. Hey, what are you trying to do here? What's important? Learn what they're doing, then think about the risks, then think about the security answers. Don't walk in using this cybersecurity framework or 62443 like a bingo card and go in and say, look at all the things we can do for you because I can't believe you're not patching your systems. It's an easy way to get kicked out. I have responded to more cyber attacks, or excuse me, I've responded to more outages at plants by well-intentioned IT people than China, Russia, and Iran combined. Okay, we got to be aware that sometimes the operations people say get out. It's because people have been there before and done it poorly. So if you can understand the mission and talk in their language and actually try to understand them before you actually prescribe a security answer, it's going to go a lot further. Okay, I'm sure that's applicable to IT, but it is really applicable in OT. All right, so with that, I think I'm like winding it down, but hopefully we'll have time for questions. But when you think about all these policymakers around the world freaking out, this is kind of the story arc of why. Since 1998, Presidential Directive 63, we've been talking about critical infrastructure, cybersecurity. But everybody went and did it on the IT side of the house, not on the OT side of the house, the critical part of critical infrastructure. Now all your governments are telling the CEOs, figure it out fast or we're going to regulate you. And some of the regulations are not all that helpful, as we saw with TSSD2 in the pipeline sector. So with that, hopefully we have vibrant questions and insights. I'm happy to answer anything that you'd like until SPAF kicks me off the stage. All right, what we got? Just don't be boring. Yeah, go ahead. Is there like people online or something or recording? They want to record you. Look at all this ex-NSA people. Yeah. Here you go, sir. I'll walk back so it's not awkward. You'll like talk to me right when I'm there. Yeah.
All right. So in 2018, I think, NIST published the special publication 800-193.
Yeah.
Firmware resilience and recovery. And yet in the 6 or 5 years since, there's only a few companies right now that are making products that have adopted that capability, like Microchip, Infineon, Lattice, even Micron recently. Where in the standards or in the requirements you've seen in government procurements have those requirements been included?
Yeah, no, that's nowhere that I'm aware of. And that is explicitly, I made two other points in my Senate testimony this past week that hit on that exactly. Point number one was, when the government talks to the private sector about the various standards and regulations, it is hypocritical when the government does not follow them themselves. And I made the point because when government agencies get, and I'm, trust me, I used to be in the government. I served my time. I bleed red, white, and blue if you cut me deep enough. So anybody's like, he's bashing on America. Hold on. All right, just the American government agencies. Anyways, so when we look at the government agencies, what happens for them to get budget? They go in front of those panels, like the Senate Energy Committee, as an example, if you're the Department of Energy, and all the problems that the senators are worried about, which is the critical infrastructure, security, they take on and say, we could fix it if we only had more authority and budget, even though they don't actually do security in the private sector, right? They're not responsible for any of it. And so there's a lot of senators who genuinely believe that CISA, as an example, is protecting U.S. critical infrastructure. No, they're not. They're contributing. They're awesome people. They're good Americans. They're not protecting it. The local power company is protecting it. So one of my statements there was explicitly designed to help the senators understand that, when I said, look, the government agencies are less protected than most energy sites in this country. And it kind of causes that juxtaposition for them. The second point that I made is about the vendor responsibility, because they were talking about more regulations on the electric sector. I was like, why? They're very well regulated. Put regulations on the vendors. I was like, I think I'm probably one of the few vendors that ever gone in front of Congress and asked for regulation. But I got up and I said, look, here's something that we do as an example. I'm not trying to brag, but I'm trying to talk to you about what you should not be allowing me to do. I said, for our software development, for our technology, we know our technology gets deployed in rail, oil and gas, glass factories, nuclear power plants, things like that. I said, so to me, it's not that one country is better than another. It's just controlling the supply chain is hard. So we've made the very costly decision to have 100% of our software developers be US citizens in the US. That sucks from a balance sheet perspective, okay? Like that is very, very costly. But now I have complete control over my supply chain as it relates to what goes in my software. Doesn't mean we don't need to do all the rest of the security, but it adds an important piece. My point to the Senate was, why am I allowed to make that choice? As a CEO of a company that services critical national infrastructure, why am I allowed to? You want to say that the Grubhub app doesn't have to do anything like that? That's fine. But if I'm allowed to sell into national security problem sets, I should probably have some standards that I have to follow to be contributing to national security. And so we right now bitch at all the asset owners and operators, and all the vendors are there in op-eds. Oh yeah, I mean, there was even this OT coalition group that stood up. I can't talk about this too publicly because I sound like I'm just complaining about competitors, but they wanted us to join and we refused to join. Why? Because they're advocating for more regulation on industrial control systems in the sectors. My point of view is that vendors shouldn't be having conversations with regulators about the regulated without the regulated present. And so I have a fundamental conflict on that. So I think the vendors are screwing.
So as a follow-up to that, the Trusted Compute Group, the Trusted Computing Group, came out with TPM 2.0. The military made a mandate. We're going to buy your computers for our systems, desktops and servers, that they're going to have a TPM in it.
Yeah.
Okay. So then along came DICE that Microsoft outsourced, but nobody's implementing any mandates that talk about recovery for firmware and monitoring that you mentioned earlier with pipe dream.
Yeah, there's nothing coming that I'm aware of on all that. The CMMC stuff is probably the closest to getting like the subcontractors involved, but all you actually have to do is define your risk profile by the standard or by the regulation. So there's no actual follow through. So the good companies will do good things, the bad companies won't, and we'll still be complaining about the bad companies.
Well, good morning. I'm Eugene from Purdue Manufacturing Extension Partnership, and I'll admit at the beginning, I'm doing all of those ineffective things that you just spent the last 30 minutes talking about.
At least you're doing something. Yeah.
Well, okay. So the part of the industrial sector that specifically we're focused on is manufacturing. What we're doing there is driven by contracting, government and DoD contracting. You want a DoD or a federal contract, you have to put these controls in place. They're focused on IT.
Yep.
So that's the need, right?
For sure.
Not necessarily focused on OT. If I were to go into a small manufacturer, these small manufacturers, less than 100 people, and say, show me your CNC machine. What's the risk on that CNC machine if someone were to hack into the OT side of the system? And they'd say, well, how does that get me to where I need to be in order to meet the compliance requirements? Totally different from effectiveness.
Yep.
But that's the problem.
Yep.
Okay. So so I did note that detection and response for a small manufacturer is pretty expensive. If I'm assuming, and I'm not sure, that if looking at the event stack, using I don't know, let's just throw one out there, Alien Vault, I can see the things that you're talking about. I don't know if I can or I can't, but it's pretty pricey for a small. So I'm looking for I made more of a statement than asked you a question. So let me get to the question then. Given my constraints, given how I'm funded to go help small manufacturers continue to generate revenue, how is it that that you think that I can do this and still help them be more effective on the way to compliance? Is the question. One, at a price
so that
they
cheap,
can
secure, and compliant.
Yes.
Got it. Okay. All right. I'm gonna solve this one for you. I wrote a paper titled 5 Critical Controls for ICS Security. It's over at the SANS Institute. You should follow that, and you could do everything you just said. But I'll give you the longer version of it, which is one of the problems that I see with most security teams is they don't know the requirements, and so they look for everything. So like the fact that you want to look at all the events in Alien Vault by a default is wrong, in my opinion, right? The whole my opinion piece is important here. As an example, what does that small manufacturer actually care about? They should be able to decide the 2 or 3 scenarios that they care about. I bet ransomware across their operations facilities is one of them. But pick out actual scenarios that have actually happened, not theoretical. I could use the Bluetooth to spin the wind turbine. I don't care. Has it actually happened? No. Well, then it's not my problem. Well, you're not being proactive. I understand that. But that's also another thing that people say, just as a quick tangent, that always gets me going. We want a world-class security team. No, you don't. I don't want a world-class security team. My company exists to build and sell software to help the companies we work with protect the people in their areas. That's what I want to be world-class at. You can be world-class at one thing. I also want to do good security, but I want to have the bare minimum of what I would consider reasonable security. Now, what I consider reasonable security is a hell of a lot more of maybe some others, but that's what I'm doing. I want a reasonable ERP system, a reasonable NetSuite, I don't want a world-class finance program. I want a world-class development team. Pick one thing, right? So your manufacturer have chosen to be world-class at what they're doing. That's great. We should applaud them for it. What are the scenarios that actually matter? There's probably like 2 for them that actually impact them on the revenue. And by doing those types of things correctly in OT security, you're probably getting visibility just for like root cause analysis of maintenance issues and similar. So there's going to be just value on the back end of it. I think a lot of IT security doesn't contribute to IT resilient, like IT in general, even though some of it does. But a lot of the OT security done correctly is just getting through the complexity to understand what the hell's going on anyways. And the ability to get root cause analysis and downtime is super core. So it actually has a lot of value. Anyways, pick out the scenarios. Then it's what can actually trigger those. What systems are relevant in that scenario? What data is relevant? And you pare down the data set, you pare down the alerts, you pare down everything to just what you actually should care about. Everything else is go hunting later if you have magical, mythical free time. Otherwise, protect yourself against the actual requirements of that business, not what we think are the requirements, which is all the different cyber risks, because you just won't ever do it. It's the SANS ICS 5 critical controls. So it's 5 critical controls for ICS security. Tim Conway and I wrote it. All right, what's up? What's next?
So looking for another opinion. 2 things. One, I spend my day doing enterprise ransomware rescue. And so I'm very interested at maybe some point having a conversation with you about what does that look like on the OT side versus IT. The other thing is on the sensor reliability of the data. If you're monitoring, you have to be convinced that the sensor data is giving you the information.
You've been reading Joe Weiss. All right, go
Joe's
ahead.
a really good friend of mine, and that's what
great.
I'm
Let's
very
go.
interested in opinion on
Let's
that.
do it.
So that's why I brought it up. So I've known Joe a long time, and that's his big thing is if you can't trust the data. So I'd love to hear what you think.
Yeah, I love Joe. Joe's been a friend for a long time. I usually refer to Joe as my Winnie the Pooh spirit animal. Call me at 3 o'clock in the morning. Rob, it's an Aurora. I'm like, okay, Joe. But super nice guy. And here's what I would say. There's a lot of like new entrants to the ICS security community that like make fun of Joe. And I want to like stop it just for a quick second. I feel like I can go toe to toe with Joe, even though 11 Death, he's been doing it longer. I feel like I've earned my ability to do that. If everybody else is like taking pot shots, let me be real clear that the guy has earned his stripes. He's been there, done that, and his opinions are valid. I don't agree with most of them, but they're valid. I don't agree with his tact, but they're valid. And further, his mentor was Oppenheimer. So like, everybody calm down for a second. The guy's like royal legacy in the community, okay? Anyways, so sensor data. I appreciate what Joe is trying to highlight. And from a process integrity perspective, the man is absolutely correct. Where he's wrong, in my opinion, is two things. One, he keeps saying that nobody's doing this. That's just not true. Like Honeywell has been doing process validation on their sensor and IO units since like the 1980s. You know, it's not true that nobody's doing this. But it is a very important thing. And a lot of engineers don't do it correctly to actually see what's going on in the process data, have a loop that may go directly to a story and a loop that then goes to the HMI, be able to see and be able to cross compare the data sets. It's very, very important. The other thing that I think he's doing wrong is he's putting it with cyber and cybersecurity, and it has nothing to do with cyber and has nothing to do with cybersecurity. Well, yeah, but you know, and then you could see in the IO, no, by the time you're looking at analog data and like an IO output, the factory's gone. Like it already blew up. Okay, if you're talking about physical impact, it blew up. So could it be useful for forensics? Potentially, but we already have all the other forensics through all the other sources we need. His statement is there are attacks that are undetectable through the network. No, there are not. There are no cyber attacks possible, remote cyber attacks that don't go through a network. So the idea that you can only do it in IO is ridiculous. What he means is once the attack goes to a certain point, there are some things like heart over serial instead of heart IP that you lose visibility into because of the way they designed it. And that's absolutely correct. But all the detection, response, recovery, everything else is already done. So if I did everything else in security and had resources left over for certain core assets and like a nuclear power plant, I'd probably deploy some of the solutions he's talking about. But he also ought to disclose the solution that he talks about the most and pitches the most. He has a significant equity stake in. He doesn't tell people that. Yeah. Yeah, no problem. All right, what else?
Okay.
Yeah.
Didi Budiharto, I'm a recovering CISO from oil and gas company. So this is mostly a call for collaboration and get your thoughts, right? As a practitioner in oil and gas company, the OT and the IT converge, not converge, has always been a political discussion. But what I've been seeing is that we need to have that three-headed monsters: the OEM, the original equipment manufacturing, the government, and the owner operators as the oil and gas companies to work together. This is the case because the owners operators are the ones being penalized right now with the TSA regulations, whether or not to comply with the regulations. Whereas there's no incentive that I've seen or I've known from the OEM to be in that compliance. So it's always us playing catch up, and the regulators are off doing something else. And those three-headed monsters are not talking to each other. And what's your thought on that?
Yeah, I would add in your integrator, and I would also add in your cybersecurity service or technology providers, especially because your OEMs are now trying to pitch their own cybersecurity offerings, which really half of them are things they should have just built into their product, but now they're trying to sell to you. So I would include those as like the 5 discussions, and then you got to put teeth behind it because we have these. CISA stood up JCDC, they try to have meetings, there's like a Slack channel, nothing happens in it. There was the DHS sponsored Logic Forum, which was exactly that in the oil and gas industry.
I'm an API, I'm the chair for the API.
Yeah, so we have all these forums. That's why every time some other new cybersecurity agency or forum stands up, you just kind of roll your eyes. You're like, yet another one. And so we have all of them. Until you actually have the stick, nothing else is going to matter. You either need to change the law around antitrust to allow oil and gas companies, as an example, to band together and say, we all want these features in a product, and your combined purchasing power can force it. But right now it's illegal to do that because of antitrust. Or you need regulations on the actual vendors themselves. But another way to do it is for the government. This will go back to the point that the gentleman made earlier. The government could also just fix this in a heartbeat. Like, everyone thinks it has to be regulatory. If CISA came out tomorrow and said, here's what we view to be the right security features on the next gen PLCs, every company would take those and staple them to an RFP and not violate antitrust. And the vendors would provide it overnight. And then DoD take their purchasing power and go, we will only buy control systems that meet to this level. you'd get everything on the market you want. But instead, they want to talk about, regulators want to regulate, policymakers want a policy, but honestly, all they need to do is have a point of view. I've asked them why don't do this, and the explicit answer is, yeah, but what if our point of view is wrong? Okay, but somebody's got to do something, and I do think that should be on government agencies that are out there like, we protect critical infrastructure. Okay, do something. Just do something.
Right.
So yeah, unfortunately, but yeah, you can fix
Hence
it like
the call for collaboration. So together we are stronger.
that. Yeah, I think we're perfect. I'll be more quiet or more concise, I guess. We already drank together. What's up, man?
You mentioned earlier about how the different vertical markets are fortunately, historically not homogeneous, which has worked out to everybody's benefit in this sense. I'm curious if the Codesys software, which I guess you could probably accurately describe as sort of middleware for these different systems.
Yeah, it's like an entire operating system in a protocol.
Right. Yeah. Do you think that made the pipe dream attacks more economically feasible because it was like this research had been done by a company that was, had a for-profit motivation, obviously, and they had put all the research and development into it. So then it could have done, but you're nodding just answers this question.
Yeah. So long story short, we've now gone homogenous. Codesys is one of a couple things that have done that. I don't advertise out what the other ones are because the adversaries do listen. And that goes to your other point about research and development. Be careful on that too, please, researchers. There is a university in the United States, it doesn't matter which one, that published a paper a year before the Trisis attack of exactly how to modify that exact version of Triconics and do exactly what the attack was. And they made a coding error in it, which the adversaries even copied. So we know for a fact they read the research paper. So when you put out like, here's new ways to take things down, like people read it, please be careful. All right, yeah, sir.
Yeah, so this is actually a good timing to actually follow up. So I have a follow-up question. So I am a academic cyber physical system security or IT plus OT security researcher. So I really appreciate the pitfalls that you mentioned to avoid, especially for academic research, and wheels that we should not reinvent in the area of cyber physical or IT plus OT. So I wonder if you might have any more constructive kind of a suggestion, what areas or what directions that we could, we in academia could focus on, given our, the mode of our operation, the resources that we do have here.
Absolutely. I would say there's just a lack of knowledge in general on how to deal with certain systems. So take the latest Honeywell Experion distributed control system. Cool. If something were to happen to it, what are the relevant data sources on it? Where are they stored? How long they stored? What's the timestamp considerations on it? UTC plus whatever. What data would you pull in different scenarios? Like, hey, if this was attacked in such a way that copied the blueprint of what we saw with Trisis, but in this type of environment, what would you do? So can I detect it? That market's got it. Can I try to prevent it? That market's got it. Can I respond and recover? Nobody's doing that stuff. Nobody's developing like the playbooks of it, and here's how to do those things. That's one of them. Another one is just the general research on bill of materials, I think is important because I've looked at every single IC. So there's a bunch of different ways to get bill of materials in software. Broadly speaking, you do binary analysis to kind of like decompose like what's in it, or you do like source code analysis. Source code analysis already done. Don't waste your time. Sneak and the others have got that market. On the binary analysis, there's like 5 companies in the ICS space that are doing it. So if you're doing it in IT, it doesn't make a ton of sense because just wait for the next version. ICS, we live with that stuff for 30 years. It's a market. The problem though is I like the idea so much that I went to buy one of those companies. So we got in advanced discussions and tech due diligence with all 5. So I won't break any NDAs by saying just like a higher level statement. I looked at all 5 and walked away thinking they're snake oil. But the other thing is worth noting, if you're doing bill of materials correctly, you're actually solving the antivirus problem. Can I accurately identify what this software is, regardless of what it tries to tell me, is the same problem, which is why the bill of materials companies, in my opinion, don't have very good viability chances, because I just don't believe that they'll solve what the antivirus industry over the last 30 years hasn't been able to solve. An unsolvable problem in a market that somebody hasn't figured it out sounds like a good research opportunity.
Excellent point. Thank you, Rob. I'm also glad to know that we are on track, the kind of consistent what you just suggested.
Perfect.
Thank you.
Perfect. Absolutely. All right, sir, over to you. Thank you.